Hello! Today we're going to talk about Topic 4, Section 19, Markov Chains. Alright, so we basically are going to represent probabilities with transition matrices. Alright, so the idea is that we're going to be able to use matrices and plug them into computers, and then therefore these computers can do algorithms based on those matrices. So for instance, think about in your video games. Okay, so you want different sunny days and rainy days, so you do prediction matrices. Okay, we can put this into a transition matrix by simply writing it like this. Okay, so the top part has today's weather, and the rows are tomorrow's weather, so what you're predicting. All right, now, the definition would be right here. The probabilities in each column should sum to 1, which makes sense because the probability that today, if today is sunny, well, it's either sunny or rainy. Okay, and that's what you start, and you're predicting it on tomorrow's weather based on that. Okay, so here we have another matrix, right? Of course, they used a different example here. So we want to find the probability that it will be rainy 3 days from now. So how do we go about doing that? Well, we plug this into our matrix. Ooh, let me get my calculator. Okay, so now that I've got the calculator, you go to second x to the negative 1. So matrix. Go to edit. We're going to do a 2 by 2, 0.75, 0.45, 0.25, 0.55. All right, so we put that in our calculator. And then we want to find, 3 days from now. So all we would need to do is multiply it 3 times. So here we can take our matrix and then raise it to the 3rd power. And there we have our new matrix. So now, okay, sorry, got distracted. So let's see. We would want to look at, given that it's sunny today, we want to look at, it'll be rainy 3 days from now. So sunny today, rainy in 3 days. You're looking at that probability. So it's 34.75% chance of it being rainy 3 days from now. So make sure you know how to put it in a sentence. All right, so here are transition state diagrams. Okay, so you want to make sure you know how to read these. It's really essentially just follow the arrow. Okay, so it's what you start with and then what you're predicting. So here, this arrow is starting when it's sunny, and then it's sunny the next day. So this one is today, sunny, predict tomorrow, sunny. And I don't know why I don't know how to spell tomorrow, apparently. Silly me, can't multitask. Okay, at least I caught it. All right, so then let's see, for instance, okay, so now if we start on sunny, and then the arrow goes to here, that's the, today is sunny, and tomorrow is cloudy. Ooh. So that was a probability of 0.25. And this one was a probability of 0.60. And then I'll just do one more. So we have one more starting at sunny, and then it goes to rainy. So probability that today is sunny, all right, what is, or the probability that tomorrow is rainy is 0.15. Now that had just 3 arrows, and we got 3 probabilities. So we put that in a transition matrix. So the weather today, the weather tomorrow. So reorganize it, make sure you label it. I would always write this out so that way you can tell what you're looking at. Okay, because you might put your matrix differently. You might put rainy, then cloudy, then sunny. Okay, so always label it first, and then do your new matrix, right? We're doing it 3 days later, so t cubed. And now, again, we're looking, it's rainy on a certain day. Find that probability that'll be sunny 3 days later. So rainy on a certain day and sunny 3 days later. So look down this same column and down the same row, and that's where we get our answer. Okay, so we use that for probabilities, but now we can use it to also predict future states if we know its current state. So for example, if we record that 589 of 964 employees are ate at the cafeteria, well, this is the the transition matrix. All right, we're going to calculate a prediction. We'll eat at the cafeteria on Friday. So what we do there is we identify our matrix, our starting one. So here we had 589, do 964. Let me get that written out. So that is that number is 964 minus 589 gets you your 375. Then using our formula, all right, so it starts with Monday to go to Friday. That's 4 days later because you're going Tuesday, Wednesday, Thursday, Friday. So that's 4 days later, which is where we get here. All right, I should probably do those as different colors so that's not confusing. Okay, so those red go together. All right, so then, so this is your prediction to the fourth power. You multiply it by your expectation matrix, essentially. You multiply, and then you get your rounded answer, right? Because you're dealing with employees, right? You're trying to predict how many employees. You're going to use a whole number. Okay, so you can have a steady state vector. So the solution is the same thing as what you started with. Okay, essentially you're doing the transition matrix times that steady state vector to get the same vector. Let me show you an example. So here we had our cafeteria and employees. So what we start with is we've got our transition matrix. All right, using this formula, okay, we can write the transition matrix times our state vector. We're showing that this is it. Well, we multiply, and now we get a system of equations. I don't know why the arrow didn't continue. Okay. Then, when we get this, we can rewrite it. All right, and now we can do a system of equations, right? But I know that's the same thing, so that just gets us two equations. So then we need our third one. We get this. There's 964 employees, so the two here should be the same number, or should add up to 964. So now we write it as a 3 by 3 matrix. Okay, so notice what I did. Okay, the Y's went here, then my N's went here. So 11964, negative 0.15, 0.10, negative 0.15, 0.10, third one. Okay, so plug that into your calculator. Okay, so hopefully you have put your matrix in. All right, so put that in a 3 by 3 matrix. Then to reduce it to row echelon form, what you're going to do is go to, the matrix. So second inverse, then go to math. You're going to go all the way down to R ref, reduced row echelon form. Why can't I say that? Reduced row echelon form. Echelon is, let's see, ECHELON, in case you're wondering, reduced echelon form. So you do that one, then you pick matrix. Mine was matrix A, and look at what you have here. All right, so that reduces it down, so then you get your values. All right, so Y would be 385, so eating in the cafeteria tomorrow, and then 578 for not eating in the cafeteria. So again, this represents the long-term probability, which you'd expect over time. So let's do it again for this example, right? So feel free to pause it and give it a try. So again, using our equation at the beginning, which I don't like that it looks like it's part of the equation. This is something separate. This is what we're basing it off of. Okay, so then we get our two equations there, and we get our all right, again, the probability that it's sunny plus the probability that it's rainy would have to equal 1. So I just want to hope you understand that equation. So that third one right there would be S plus R equals 1. The third one, or the top one. Reduce row echelon form, then you can convert it into fractions, right, by using your math fraction button. And then you get the long-term probability of it being sunny, all right, was our top one, so it's 9 out of 14. Okay, so that's the long term. That's what we expect to happen. All right, it's kind of cool, right? All right, now you want to make sure you, of course, understand the words. So long-term probability matrix, that's just in the long run. So here we found that it was 9 over 14 for S and 5 over 14 for it raining. Well, the matrix is still the same size as it was before, right? We had it today. That does not look like today. All right, today was either sunny or rainy, and then we had tomorrow was either sunny or rainy. And we found sunny to be 9 out of 14 and rainy to be 5 out of 14. So we used that and just replicated it. Okay. So, again, you can also find long-term probabilities. There's another way of doing it as opposed to doing it with these, reduced row echelon form. You could just put in as a really large number and then have your calculator convert those decimals to fractions. But really, you know how to calculate these probabilities manually because you might need to show your work. Okay, and it's really not that hard to show your work here. Okay. All right, so this is what you should know at the end of this topic. Hopefully this all makes sense. Yay, we're done with topic 4, the biggest section of our IB exam. So if you have any questions, please don't hesitate to ask.